Good evening, doctors. My name is Mostafa Metwally. I'm our group leader, and it's my honor today to present to you this project. While it would have been our honor to present to you this bridge face to face, however, the COVID 19 circumstances have prevented this honor. First off, I would like to start by talking about our team's name, the Pixies. It might seem meaningless, however, it describes our enthusiasm and teamwork to construct and present our bridge. And we hope that this presentation was to satisfaction.
Hello doctors, my name is Habiba Hisham. I will complete the presentation after Mostafa. It's an honor to present to you our Bridge of Tribethia, which is named after a famous book called Bridge of Terabithia, but for little creativity we changed it to Tri. As you can see, our bridge consists of many triangular shaped parts. The fence, the truss, and also our supports. As freshman engineers, we had no idea how we would build a bridge with only sticks and glue. It was challenging. Our story starts with one layer of truss, a thin layer of bent railway road, and no idea how we will cut the opening in the roadway. However, after countless debates and numerous trial and error experiments, here we are with a triple layer truss with a strong and horizontal railway road and a perfectly cut opening, not to mention our strong supports. There are 6 stages of this project. The first one was to fully understand the requirements of the competition. After reading the slides provided to us, we had to highlight all the important parts to make sure that we fulfill all the requirements. The second stage was researching and brainstorming different ideas via the internet. The third stage, there were some trial and error experiments. We didn't like failing at all, but it was the only way for us to learn. The fourth and most challenging stage was the obstacles that we faced, but we managed to rise above it and we found solutions, which was our fifth stage. And last but not least, success was achieved.
Hello doctors, my name is Salma Osama and I'll be continuing after Habiba to explain the construction process we followed. First of all, we googled different websites and we have done different and copious researches on how to make a bridge that can bear load and at the same time is light and cost efficient. And also we watched many YouTube videos done by engineers and students from different universities from all around the world who have done something similar to that competition in order to get information that could help us as much as possible. Not to mention that we consulted some of our friends and family members to make it easier for us during the construction process. As shown in the sketch, our bridge consisted of 2 supports with the innermost distance between both of them 75 centimeters and the height of each was 11.5, and also trusses with the height of each 12 centimeters, and each truss was made of 3 layers to make it as strong as possible. Also, our railway road with a span of 98 centimeters and it was made of 2 layers that was stuck to each other in a certain sequence to make it bear as much load as possible, and also an eye-pleasing truss on top with a height of 10 centimeters. In order to make it easier for us to construct the bridge, we drafted the sequence we're going to follow. First of all, we started by constructing the major supports, and then we moved on to making the railway road, and afterwards we started constructing the trusses, and then the inner supports, and then finally, which was actually the most challenging part of all, we connected all of these parts together. To start off our construction process, we used a 10 by 10 layer of sticks to place the triangle-based supports on it, which means that, as shown in the picture, each support was made of a triangle shape of sticks stacked on top of each other.
Hello, doctors. Mustafa Mtwali back with you again. I'll be picking up from where Salma left, continuing the construction process, specifically the construction of the trusses. As you can see in this picture, we have inserted binder clips in specific areas where we found that the contact areas were minimum. This helps the sticks stick together until the glue hardens, and we got this idea from a YouTube video that we came across. After constructing the roadway, the bridge seemed a bit naked, so we decided to put these triangular-shaped fences. After all, you wouldn't see a real-life bridge without fences, because you wouldn't like cars to drive off of it. And now to the main part of the bridge, the trusses. I call it the main part of the bridge simply because it will potentially withstand the entire load of the bridge. It wasn't an easy task to perform, however, after an entire day, we were able to build a AAA truss that could finally stand on its own. That's it, and I'll be leaving you with my colleague, Sherif Hatem.
Hello, my name is Sherif Hatem Mohamed Ibrahim Abdalla, and I will be continuing the construction process. In order for our truss to remain upright, we had to use sticks layered on top of one another, either side of each truss, on either end of the bridge, in order to hold the truss upright, so that when the bridge is loaded, the truss remains upright and does not fall over on its side. How is our load transferred to the supports? When the bridge is loaded, the weight is transferred equally along the entire length of the truss. The truss then passes the weight onto the two major supports, and the truss and the supports bear the weight of our load, as you can see in the picture above. Obstacles that we faced. Limited time to build our bridge, as we had just finished our midterms. Visible road curvature preventing adhesion of our road to truss and supports. Sticks that were falling apart before the glue had hardened, and we used binders to fix that. The 2x2 opening in the roadway was very difficult as it required use of sharp tools. The truss did not stand horizontally on our support, and we fixed that by using the layers of sticks on either side. The most difficult obstacle we had faced by far was keeping our roadway flat. We had to redo our roadway twice until it became flat. The road is what linked the support, truss, and triangular-shaped fence all together, so it was the heart of our bridge. It was imperative that we prevent it from bending so that it could glue all the parts together. This is a picture of a failed roadway that came out curved.
Hello doctors, my name is Rana Hatem Mohamed Ibrahim Abdalla, and I will be continuing after Sherif. As previously mentioned, our most difficult obstacle was ensuring that the road was flat. After 2 failed attempts at making a flat road and considering many possible solutions, we attempted to place heavy water bottles on the road while the glue hardened. This finally led to the flat road that we were hoping for. The construction process was difficult and tiring, but through it we managed to learn to be patient with one another and tolerant when faced with opposing viewpoints. Furthermore, we learned not to rush into things, but rather be meticulous when planning and thinking everything through. Each of us had a task that we were trusted with. This led to us learning to be responsible. Since we had to overcome several large obstacles, we learned to value cooperation and working as a group to solve problems. This project allowed us to acquire several invaluable skills, such as the ability to think critically when faced with problems. Attempting to build a bridge out of nothing but wooden sticks and glue was no easy task. Hence, we had to have strong management skills in order to allow us to work together smoothly. As we are all freshman engineering students, we lack experience, so it was important to listen to each other's feedback in order to fix any mistakes. Thank you.